Hello, everybody. I'm going to kick off just a couple of minutes early because then Chris will be bang on time when he starts. So, hi, I'm Ruth Evans, CEO of BFBI, and on behalf of Lineview, welcome to our breakfast briefing on unlocking hidden capacity in your production lines with line balance optimization. You've been automatically muted to keep feedback to a minimum, and we would ask you to also switch your video off to keep bandwidth to a maximum. If you have any questions during the presentation, please do post them in the chat, and I'll ensure that all questions are fed through our presenter, who is Chris Spray, Lineview's Operational Success Director, at the end of this presentation. Any specific organisational questions you'd like to raise with Chris offline, please do contact him after the webinar. At the end of the session, we'll be sending out a feedback form, which helps us understand how we can improve, gives you the opportunity to suggest future topics of interest. We really would appreciate it if you could take the time to complete. The briefing's being recorded, and we will post this on our YouTube, Facebook and LinkedIn channels in the coming days for you to revisit. And the slide deck will also be sent to you when we send out the feedback form. So it just leaves me to say thank you for supporting our event. I hope it provides information to support you. And I hand over to our presenter, Chris Spray.
Thanks very much, Ruth, and thanks for everyone for joining this morning. This is quite a technical update, so I ask you to bear with me. And as Ruth says, if you've got any clarification questions, please just throw them in the chat, and just we can make sure everyone's along with us. I'd also say in a few minutes' time, we're going to ask you a few questions. So getting thinking caps on will be useful about your current knowledge about line balancing. But this really is a presentation just to introduce you to some of the concepts we use. We probably do 100 interventions a year around the world, and we regularly find 2 to 5% of increased capacity and increased production throughput through the processes we use. I've just written some of the ways we improve there in terms of KPIs. In terms of agenda for today, just give you a very quick overview on Lineview if you're not aware of what we do in the market, and then a short quiz, just 3 questions about your understanding about line balancing, and then I'm going to just share with you some of the ways that we work with lines to optimize flow, and also some of the reasons why they, lines aren't at optimum right now. I quite often get asked by senior people in organizations, like, I've just spent 20 million pounds on the production line. Why isn't it at its optimum? And there are some reasons for that. So we'll flow through to a Q&A at the end. But as I say, if you've got any questions in the middle, please do throw them in the chat. So a very short thing about Lineview, 24 years in operation now. We combine global expertise in operational excellence and in the beverage industry. We also work in a lot of the food industry now as well. We've got a team of people that roam the world, and my team actually use our digital tools and our digital technologies to drive performance in the industry. And it's great, enjoyable work, and we're really proud to be connected with some major players in industry. Over 700 systems now in the world, 20 countries, and we've also got local representatives that work with us, and a big team and growing team. This is just the UK team. We now have people in the States as well, and in the Middle East and the Far East. But you'll get access to this and be able to see the credentials of our team. So a quick quiz. I'd really love, let's just do question 1. I'd just like to understand people's general appreciation and understanding about line balancing. Some of you might think these are Mickey Mouse questions, but I just want to make sure everyone's on the same page. So, what is a bottleneck machine? I'd love ideas and thoughts about that in the chat if you could. the slower one. Yeah. Any other thoughts? Great, Mark. The critical asset which detects the speed of the line completely. Bottleneck machine. Yeah. Yeah, great responses. So typically you'll have a machine on the line that is often the most expensive, and that determines the whole rate of the production line. And, you know, it's really important we keep that machine running. If it stops, we're not winning. Great. Slowest machine, critical machine. Brilliant. Thank you. Yeah, causal loss. We are only as quick as our bottleneck. Thanks, Pierre. Great. So question 2, what is the role of accumulation on a production line? Love your thoughts on that. Yep, completely, Kyla. Accumulation allows other machines in the line to carry on running even when the critical machine goes down. Actually, it's probably the other way around. So accumulation allows the critical machine to keep running even when the lines around it, even when the machines around it are broken down. Yeah. Stop critical machine as least as possible. Yeah. And a buffer. So yeah, some good answers here. Thank you. Let's just move on to the third one. So, you know, if you're working with a really well-balanced line, what sort of things would you be noticing about it? What would be going on? Bit of time to think here. Probably a longer answer. Regular flow, V-curve. Yeah, so V-curve, consistency, calm environment. Thanks, Gavin. When minor breakdowns occur, critical asset continues to run completely. Yeah. Yeah. So it's all about flow. I mean, line balancing is all about maintaining flow of your critical machine and keeping the critical machine running as long as possible. Great. Thanks for your answers. I just wanted to, yeah, consistent flow, smaller variation, completely smaller variation, Bruce. Thank you. Ability to handle minor breakdowns. There we go. So I think we're all on a similar page. Thank you for that. Please continue to, if you're thinking, check it in the chat. Okay. Thank you. So yeah, as we said, you know, most lines we encounter as Lineview are not in perfect flow, and our view of perfect flow is something like this as an analogy. So if you imagine a production line with a small bottle running through the line, and the conveyors act as buffers, or the accumulation conveyors work as buffers, and you have varying machines down the line. You'll notice the constrictions increase as we go down the line. So as we get into flow conditions, we have a condition called, we have the critical machine, the nominal state. So it's flowing through the line, but if we get a stop in the line further down, it builds back. We start building into this buffer, but still the critical machine is flowing. And it may stop another upstream machine and build back to the point where in a moment you'll see the machine below empties as fast as possible to maintain the critical machine in its nominal state. And we get back to the line just flowing through. And you'll notice above the constriction, we're doing as much as possible to maintain as much of a buffer ahead of the critical machine as possible. So that's perfect flow and the ideal condition. So why is it so many lines have hidden production opportunities? These just a couple of live examples here of a line poorly balanced. You can see here very little accumulation of availability on this line, and I just encourage you to go out on your production lines and just see how much accumulation do you have available to you? This line's clearly just been used as transport. Sorry, as storage, not transport. Whereas this line here, you can see lots and lots of space down the line where accumulation can occur. But often machines aren't locked down, so they're commissioned, and then the engineers and the operators start to have a nice fiddle, and the original settings aren't taken into consideration. I would say, and I'd probably get shot by the OEMs for this, but they're not great at machine integration. They're really good at producing great quality assets, but when you bring them together in a dynamic situation, there's little understood, particularly by the commissioning engineers, about how to manage this. And what they're often trying to do is manage the individual assets rather than the whole line. Engineers change setups, often in response to problems. I was on a line yesterday, and there was clearly an extra 2 or 3 minutes of running available ahead of the filler when a bottle blower fell down. But at some point, the engineers had moved the stop point way down the line, and that was causing a problem. What they don't do then is move it back again once the problem's been solved. Often we add new products and new assets onto production lines, and they're not optimized. And the other thing is, we often find this is poorly understood at the front line. So the more we educate our people, the better. And I guess the final piece is, we do get blinded by familiarity. Maybe, we come onto a production line, that's all we've known. So I think there's a big piece to educate. And as I say, 2 to 5%, it's worth going at for very little effort often. So what we do, we often go into the field and we find these quick wins. We've been applying this to hundreds of production lines. Often no capital expenditure required, just a little bit of control engineering to get the best. And why is it so critical? We've mentioned some of these things already in the quiz, but when you flow, when it's efficient, it's optimal speed, the critical machine keeps running at its design efficiency. And we find these bottlenecks regularly, which add cost. So let's think a little bit about how we can look at and understand some of the issues we see on production lines. What's the size of the prize? Let's give you an example here. So, imagine a bottleneck machine stops 3 times an hour for 2 minutes. Maximum potential savings available, 10%. So a 10% loss because the bottleneck is regularly being stopped by up and downstream machines. So that's what we're targeting. Imagine we can get at 50% of that. Some of the lines we work on running at 2,000 cans a minute, 1% is around about £1 million of performance, of potential improvement. And many can lines around the world are capacity constrained at the moment. So potentially big money here to save a few minutes here and there every hour. What's it worth to you? Are you aware of what a 1% improvement is worth to you? It's a question. Often we don't get an answer back from customers when we ask them. Okay, let's just look at some of the principles. So production design, we're designing around this critical machine. It's the slowest, typically the most expensive item on the line, normally a filler. I've seen cooking processes, extruding processes in meat and pet food, often the bottleneck. And we measure that around the slowest machine. And we know about V-curves. We've mentioned V-curves in the quiz. All equipment coming into and out of the line should run faster than its neighbor. V-curves kind of generally understood. And if we plot these speeds, let's think about a line regularly, 10% uplift for each machine you go down and each machine you go up from the critical machine. There's our V-curve. And then we build in this accumulation as well to try and stop upstream and downstream machines impacting. So there's 2 ways we can think about, and again, just building the case for line balancing, think about maintaining uptime. We can prevent machine downtime. You know, we all have engineering teams. We all work on increasing mean time between failure, reducing mean time to repair through our training. There's a lot of investment in that area. But then through line balancers, we can minimize the impact because lines are always going to stop. They're always going to, at some point, have breaks and cycles. So, you know, many of us spend a lot of work on this prevention work. And I think we could spend an awful lot more on this line balancing work. I think, you know, the food industry can teach the beverage industry a lot about this as well. So yeah, machines always break down. Optimizing the line balance minimizes the impact. So, you know, covering both bases. What's our goal of line balancing? Well, 3 basic goals. And one of the areas here, well, let's talk about the 3 first. So maintain the critical machine. I was in Texas recently, and a kind of cowboy leader of a plant. Well, he was an actual cowboy. He said, "If you ain't spinning, you ain't winning," and that kind of stuck with me. And then upstream and downstream equipment, when that fails, you maintain the critical machine, and then if the critical machine stops, this is the other vital part, we restart it as fast as possible. I've been working in the plant the last couple of days where it took 2 minutes to restart the filler after a labeler restarted. Well, we can halve that. We can add a minute every stop, and there are 5 stops an hour. 5 minutes gained, nearly 10%. So one area we kind of don't think about as much as we should do, because we all think about automation. We all think we can do something there. But what about response times? Are faults clearly indicated on the lines? I go to many lines, and it's, you know, we're putting fewer and fewer people on lines. Are the andons working really well? Are they in the right place for the operator so they can really understand where the problem is? Can they be seen in a line of sight? And do they identify where the problem really is so the operator can get mean time to repair down? Often on lines, when lines are moved around, the ergonomics of the operator are not considered in terms of the ergonomics of the problems that might occur. So you see steps over lines, and you see restarts 100 meters away from where the problems are occurring on the line. So really important to think about response times and where problems are being indicated. And then, of course, in terms of automation, is your equipment networked? Are the machines and conveyors capable of variable speeds? And do you have minimal operator intervention? So kind of speed set points are locked down to avoid this movement over time. There's kind of a creeping 1,000 cuts of death when it comes to line balance optimization. And then have you got indications and automatic timeouts of manual adjustments? So quite a lot of plants now are allowing a small amount of adjustment on the front line, but at the end of the shift, it just reverts back to the original settings again. So that, you know, people have ability within shift to make adjustments, but not over the whole system over the whole year. So almost always important to start with thinking about your equipment. And then we start to think about in terms of automation and maintaining the critical machine in running mode, this accumulation question. So we think about dynamic accumulation, and I've got 2 pictures here on the right here, which are the similar pictures to earlier. You know, the top picture there has very little dynamic accumulation in there. It's really using the conveyors as a store of cans rather than a transport device. So there could be, if we sped up those conveyors, far more ability for that line to recover fast or stop the critical machine breaking. Down below, much more space on the line. So just to kind of indicate that, if you've got a non-optimized line, often half of the conveyors are full of product as the line is running. So it's a really simple test to me. Whenever I walk around a line, that's the first thing I look at. How full are the conveyors in normal running? an unoptimized line, you've often got, very little conveyor. So as in the hourglass earlier, you've got, real flow straight down to the secondary machine. So what happens in a stoppage situation? Well, we've already stopped M1 in the non-optimized line, and we've got twice the amount of accumulation available to us in the second situation there. So that's kind of line balance 101. How much dynamic accumulation have you got? Often engineers will turn conveyors down to stop bottles falling, rather than dealing with transfer issues or wear issues on conveyors. That sort of thing moves us off our center lines. So kind of the key thing is transport, not storage. Storage is a complete waste of time and money. We may as well just block machines together. Now let's think about cascade control. I'm not sure if everyone's aware of cascade control and how it works. And this is about restarting your critical machine as soon as possible. As I said earlier, I've recently been online. It took 2 minutes to restart a filler after a labeler restarted. The labeler actually stopped waiting for bottles from the filler. So what you can do is cascade control. So let's think about this in brief. So imagine you've got 2 lines here. M2 is blocked, broken. It's red, okay, and M1 is blue. It is built back. Both lines are the same. They're both built back. Let's see what happens. In an optimized line, M1 started straight away. M1 hasn't started on the optimized line until you're about 50%. So the second line recovers so much quicker back to its nominal position, and M1 has an extra, often more than 60 seconds of running time in play. So cascade control, often not quite understood by controls engineers in factories, because you need some safeties to ensure that you don't build back into your asset. But cascade control is highly possible on most production lines today, and it's a real winner to keep the critical machine running after a stoppage and starting it as soon as possible. Okay. So as a guideline, earlier I talked about transport and storage and conveyors. As a guideline, after a restart, if you see a gap in your conveyors waiting for product to run by after a restart, there is always scope for improvement. So just a very quick kind of thought there when you're looking around your lines. Let's just think about the effect of the V curve. I think everybody sort of is aware of V curve, but imagine 2 lines running. The second line stops, and the first machine, goes into build back. So there we are. We've built back to the main machine. When we're optimized, the downstream machine has a much higher overspeed capacity. Now, people often say 10%. I say work at the design speed of your machine, maximum design speed of your downstream machines, to clear this buffer as fast as possible. Quite often there's a lot more in capability in the machines than the OEMs will account for, because they've sold you a certain speed on your line. But if we look at an optimized line versus a non-optimized line, we'll see that the rate of improvement back to the nominal condition is much better. So what we end up with in the first is very little dynamic accumulation available, because the second machine there is not running very much higher than the first machine in terms of speed. Often we can get back to nominal position much faster than we think we can. Sometimes it takes an hour. And actually, if you increase the downstream machine speeds, it's a real winner. So let's not have speeds very similar across our lines. Let's get these V curves as V as they possibly can be, whilst maintaining the reliability of our downstream machines. Just a factor here about mean time between failure and mean time to repair, because what we're trying to do in line balance is, firstly, we're trying to make our mean time to repair less than our accumulation space. So thinking about that, again, we'll supply this to you later, but essentially we can work out our dynamic accumulation, our accumulation space, by looking at the amount of capacity on our line and the speed of the feeding machine. We need to make that less than the mean time to repair. So if M2 goes down, it will normally come up faster than the accumulation will fill up. And then the other thing to think about is to ensure that the mean time between failure of the second machine is greater than the recovery time back to nominal state. So if your machine's stopping every 10 minutes, you need to get back to nominal state in less than 10 minutes. And then you will keep M1 running. So it's also important to work in conjunction with looking at mean time between failure, mean time to repair, to design the right amount of accumulation in your line. Let's just think about the effect of good line balance. So a plot below, just imagine that you've got build back stoppages on a critical machine, and we've grouped these from a typical line. So 0 to 30 second stops, 100 minutes a day. If we added 30 seconds of accumulation to the production line, effectively we remove that 100 minutes of downtime and we move everything to the left. So all the stoppages less than 30 seconds disappear from the line. And then the idea of restarting machines much quicker, if we improve that by 30 seconds, we actually move everything to the left. So that takes 30 seconds off every single stoppage, which then improves throughput dramatically as well. So good practice on line balancing is to understand mean time between failure, mean time to repair, and really understand all these different factors that dynamically create a better solution. We talked about this a little bit earlier. But 1% of efficiency on a line is 36 seconds. So if we can, and it's also 30,000 an hour, an extra 300 products out of the line. So we could easily remove often 300 products from the line to increase dynamic accumulation and increase the amount of efficiency we're getting. Often we see on dynamic accumulation, you could fit a whole lot more product on your production lines in a build back situation to actually increase the amount of accumulation available, if that makes sense. So just some of the key indicators, I've given you a few indicators of what a great balanced line looks like. So, it's good to start reviewing this. So when a problem occurs, is it clearly indicated? Can the operator see the root cause? When you're in lack, so when you haven't got product available to run through an asset, is there the minimum amount of product on that lack? Could you actually run a bit more through the machine and actually keep the machine running a little bit longer? When you're building back the line, have you got the maximum amount of product on the line downstream of your machine? Often there's an opportunity there. During production, we've got this transport situation, not storage situation in your line. And when a breakdown occurs, everything runs for as long as possible. We're not going into half speed early. We're just trying to run as long as we possibly can. And this, when restarting, everything restarts as quickly as possible. It can be instant. You can block a labeler and a filler with accumulation between them, that as soon as a labeler starts, a filler restarts. That can be done with the right control in place and the right safety measures. And then moving to maximum speed, not just this 10%. Everyone has 10% in terms of V-curve in the head. And then after a breakdown, the line recovers to its nominal state quickly. So they're the key indicators. Oh, we have some more. Yeah. Oh, once we've got back to our steady state, get the machines down to a steady speed, no hunting and fluctuating. We quite often see machines hunting up and down, above and below the critical machine speed. Machines don't like doing that. They like to run a nice consistent flow. And some of the characteristics of a well-balanced line. They run at rated speed. They operate in automatic with minimum input. The stoppages are indicated clearly. They're much more resilient. You get much less variability, and they restart faster after a breakdown. And they recover to their nominal very quickly. Things we've discussed already. Okay, so at Lineview, what we do is we incorporate everything I've spoken about into what we call the 5 levels of control. We use these 5 levels of control as key indicators, and we've developed these principles to evaluate a line, and we have a program around this around the world. But our key principles are looking at equipment control and monitoring, looking at the speed, the line balance, looking at the conveyors, optimizing them, looking at cascade, and looking at automatic linking of speeds. And we can review those and audit those with you and actually give you a score based on that. And what we've done with many of our customers, we pioneered this with Coca-Cola Enterprises back in the day. But we know if you increase that score over time, you will get better output of your production lines. And here's a case in point. This was a European plant. And you can see there, the line efficiency was about 73%. We started working around, I think, week 47. Sorry, we started working on that sort of through the diagram when the yellow bars appear. And, moved the score up to the 70s. And with that, the line went from 73 to 80. So, we've got a proven record in this now. We're starting to see some great results come through. And another recent intervention, here's a production line that grew 9% after we did a load of work on line balancing. But also then that highlighted, what we were doing is restarting the filling machine really quickly, and that highlighted downstream issues in the line that had been masked. And then when they were dealt with, the green line there shows 2 sigma variation. You can see how much more in the last month or so, that machine has become much more capable, much less variation, and running at nearly a 9% improvement in performance. So it works, and we're proud that it works. Just a little comment though, if your line is running in the 80s and 90s, the opportunities are going to be fewer because you've got fewer stoppages. Lines running in their 50s to 70s is really kind of the sweet spot for line balancing, because you are then kind of kicking it on. If you think about it, you will cannibalize the improvements if you're actually working an asset and improving an asset. But generally, that 50 to 70 sweet spot is where most lines generally are running. So I'm just conscious of time, and I want to make sure that there is some time for any questions. But we do have a program around this. We've got some real experts, but our zeal is to kind of teach a man or woman to fish. So we bring our people to your people and train them. Train them in these 5 levels of control, train them in perfect flow, actually then do some interventions on some production lines with a couple of SKUs. Obviously, line balance and different SKUs and different bottle sizes change. And then sticking with you with a regular review of this 5 levels of control process. So, a real coaching time. There's so much churn and turnover in industry at the moment. It's really important to keep this knowledge fresh. I think the average time of a team leader on a production line right now is 18 months to 3 years. So maintaining that knowledge in-house is really important. And I think doing that in relationship is important too. What we also do is set these baseline scores so they can be referred back to, so we can actually see whether a line has moved off its target. And we often use our software to do that, but we can use others as well. And then we do have automation capability within our remit as well. We have a number of people who can come in and help you actually drive these issues out. And again, I know automation is a really scarce resource within manufacturing right now, and we have access and we can help you move this very quickly. Just some endorsements. We've recently done quite a lot of work at Britvic. I'm currently at Britvic today doing a line balance exercise, and we're finding some great improvement opportunities. But one there from San Miguel and AG Bar as well. And really, if you can get behind these 5 levels of control, really understand them, it becomes second nature once you walk on a production line to understand whether it's in balance or not within seconds. So, just a call to action. If you want an assessment, or if you want to work with us, then just please reach out. We'll discuss it. We'll share some more thoughts and share how we can help. And the offer is there. Sorry, I see a chat question there. Come back in a moment. And that's it. Any questions? Ooh. Ruth, sorry. I can see there are great benefits in training staff on the equipment in place, but is there also benefit in training prior to making capital expenditure? Yeah, absolutely. This is something that was drilled into me when I was leading projects for a couple of companies. And I think it's really important that project engineers properly understand line balancing and integration. They tend to sort of rely on the OEMs a little bit too much, I think. So yeah, thanks for that. Any other questions?
I can't see any other questions coming in, Chris. But obviously, anybody that does have questions, please contact Chris direct, and he will obviously go through those with you. So, Chris, it just leaves me to say thank you for a very interesting and valuable presentation. I defy anybody not to benefit from that. Even for me as a non-technical person, I can see how the principles that you have there in place are way beyond a production line. So thank you for that. And this will be put onto our YouTube channel and sent out to those participants that have signed up. So again, thank you.
Thanks all for your input earlier. Really appreciate it.